and welcome to the Thoughtworks Technology Radar. I am one of your regular guests, Neal Ford, and I'm joined by another regular co-host today, Rebecca Parsons.
Hello, everybody.
We're joined today by two of the members of the Doppler group who helped to put together the Thoughtworks Technology Radar, the report that we put together twice a year that's crowdsourced from our projects. One voice that you will definitely be familiar with because he's also one of our podcast hosts, but he's sitting in the much more comfy guest chair today. We're joined by Scott Shaw and then Erik Doernenberg. I'll let each of them introduce themselves.
Hi, I'm Scott Shaw. Yes, thanks for driving today, Neal. I'm gonna be the guest. You can ask me questions. I'm in Australia, and I sometimes host this podcast as well.
And hi, I'm Erik. I'm based in Hamburg, Germany, in Europe, and I'm normally a guest on this podcast, and I'm really happy to be here today.
And today we are talking about the Thoughtworks Technology Radar. As I mentioned, we put out twice a year, and it's very much crowdsourced from things that have worked well on our projects. And so that's very much generated from real project work. But the only thing that we really generate as a group are the themes. And as we are discussing all of the various things to make it on our radar over the course of the week, at the end of the week, we try to take a step back and say, did we see any sort of connective tissue between all the individual, very discrete blips on our radar? Is there something that kind of holistically ties them together? And that's what leads to the themes. We generally have 3 to 5 themes on each radar. And what we're going to do today is talk a little bit about the themes on our most recent radar, which was volume 29. Which came out in September 2023, and talk a little deeper about each one and a little bit about how that theme came about and some of the discussions around it. And so we can start with AI-assisted software development, which was our first theme and definitely probably the biggest topic of conversation for the whole week this time.
Yeah, we get asked about it a lot. This is obviously squarely in what we do. And the value that we bring to our customers, and of course our customers ask us what our experience is all the time, and I think we do have some experiences to share now. There's been quite a bit of experimentation that's taken place. I think one thing that I've noticed is that people go immediately to coding assistants, and there were a few coding assistants on the radar. The Copilot being by far the most best known and widely used, but there are a few others on there, and there's some open source ones too, which I think is really interesting. There's some open source coding models, but we find that people may be overly optimistic in the productivity gains. That's another word we should talk about later, but the efficiency gains that they might get from using coding assistants alone.
Yeah, I was personally really surprised. I mean, I had certainly played with Copilot and had seen a lot of the hype around it. And I was surprised to see some of the other tools. And while I have not personally used them, in the group when we discussed them, it became clear that these are really serious alternatives to consider. Some of them really having areas in which they work better than Copilot. So definitely worth checking out. As Scott said already, open source was interesting for me also to see that they're not really foundational models, but there are pieces that allow you to string together tools. But what was also maybe not a surprise, but I kind of didn't know what would happen, but something to do with security in that space already again. And of course, the moment you introduce new technologies, there is always the possibility to exploit it in a way that was unintended by the authors and just taking old patterns. And the one that we have then in the end highlighted on the radar are these hallucinated dependencies. And basically what is happening, I guess everybody's familiar with the idea of the large language models making up things with great confidence. But of course, if you're generating code, almost all the code you generate today includes other packages that you depend on. And if you get that wrong, you're trying to include or import a package that doesn't exist. And here it is exactly where the people, the malicious actors, spotted an opportunity. They thought, if this doesn't exist, but it is commonly recommended by an LLM, why don't I register that import? And then, of course, the bunch of developers would use it. The hallucinated package is no longer hallucinated because now it does exist. And the hackers have found a new way, the hackers in the malicious sense, have found a new way of actually getting onto the developer machines. So it was, as far as we were concerned, only one of them. But it was really interesting to see how that wave of new tools immediately brought a new attack vector.
Well, it's even worse than that because of the way the LLMs work, if that hallucination starts getting pulled into a lot of projects, it'll start being not just a hallucinated dependency, but a real dependency that shows up all over the place and grow sort of organically. So that it's always fascinating, the second order effect of some of these things that look beneficial, but then you start following implications and it goes to interesting places.
One of the things that was interesting to me is, most of us, because we manage the radar while we're writing it in Git, a lot of us use VS Code to write Markdown when we're writing the radar. And unbeknownst to me, Brigitte had enabled the GitHub Copilot for Markdown while we were doing that writing. And I all of a sudden started getting paragraphs of text suggested to me by Copilot. And sometimes the next sentence was uncannily accurate in what I was thinking about writing. And I have to admit to having accepted those once they were inspected.
Yeah, what I noticed worked for me. My workflow is often, I don't know whether everybody on the podcast knows this, but we have meeting minutes from the radar meeting, from the Doppler meeting captured, and I usually paste them into the Markdown file to remind myself of what was discussed in the session when I write the blip. And then further, of course, helped the large language model because now I was providing context almost in a RAG style. I was providing content about what I was going to write. And in that case, exactly as Scott described, I never took a single sentence entirely that was suggested to me, but I did find it, even for writing text, a helpful tool in that regard then.
It's a great way to solve the blank canvas problem in writing because some people hate starting something but love revising it. And so even if it's not great, it's a starting place and you can start revising it towards something that's much better. So
it also produced paragraphs of gibberish half the time. Yeah. But the next sentence was often really good.
Yeah, and one last thing I remember from the session that also came up is that we also immediately saw a blurring of different tool categories. We had put tools like SourceGraph and Cody on the radar before, which were analyzing code, and we were now seeing, but also at this stage, speculating how these tool categories would not necessarily merge, but how they would learn from each other. And that is, I guess, something that we will see when we, in a few months' time, build the next technology radar. I'm looking forward to that already.
I want to comment because I know lots of people are very interested in, how the sausage gets made. And one of the things that we had to do just because of the sheer volume of Gen AI related blips was we used a separate way of visualizing them and came up with broader categories that allowed us to hone in on specific things like the coding models or other tools supporting different aspects of the software development, software delivery lifecycle. And that helped us simply manage just the volume of the blips that we were dealing with. And this is something that we have not experienced in the entire history of the radar. Even when we've had a lot of blips, because they were just so dispersed, we didn't need something like this. And so we did actually kind of separate out all of these blips and used a different process to go through and winnow them down, which is a big part of what we have to do in the radar meeting, is just decrease the number of blips.
Famously on our radar, one of the most chaotic periods that a lot of us lived through was the JavaScript explosion and how much chaos there was. In fact, we had a theme many years ago that the JavaScript ecosystem settles down to merely chaotic. But we've never seen so much, and at least for me, it was extremely beneficial to take the vast number of blips we had and do some extra categorization and subcategorization to understand how they related to one another, because it's easy just to lump them all into AI, but they're very different things, different levels of abstraction. And in fact, that's a nice lead in to one of our other themes, which was about a specific part of that categorization that we did, which are LLMs, or the large language models themselves. So another one of our themes was a large number of LLMs, which talk about the use of the big public ones, but also the use of people building their own for a variety of reasons.
And I guess that experimentation, because that is what it was in the 1 year that OpenAI has now published GPT, or ChatGPT, I should better say. That amount of experimentation also then followed with the release of Facebook's Llama and so on, that came so quickly that resulted in the amount of blips that Neal was just talking about. But LLMs in particular, I think really caught, at the heart of it, caught all the geeks' attention and really invited people to experiment more with the tooling than with actually the solutions. And that was something that we also remarked on when we did this. And when we were faced with that large number of different blips, one way of cutting back to a manageable number was really to say, how much is really just people playing around with just wanting to make it work? And I think we also discussed some of the variants of LLMs that run on hardware as lightweight as a Raspberry Pi, and said that is maybe interesting from a pure perspective. You do it because you can do it. But this is maybe not, this is probably the weakest one. That is probably the ones that we would not necessarily put on the radar, and would focus on the ones that actually help us solve real problems. And in that, we just managed to get back to a sensible number. But yeah, there was a large number, not only of LLMs, but only the related technologies like quantization and so on, to actually let the LLMs run on a number of different hardware architectures.
I'm sure we're going to have another crop when we get together in a couple months to do the next radar, because this is as with all things LLM, everything we say today is probably going to be invalidated and out of date tomorrow. So there is a whole new crop of LLMs now that we're going to have to talk about and assess, which is great. But I think the big well-known models like Anthropic's or OpenAI's seem to take all of the attention, when I actually do see there are a number of organizations, particularly those with particularly sensitive information, or those who might be in regions where they can't be assured of the sovereignty of their data, that want to do self-hosted models. So there are a lot of people asking about self-hosting and using the open source models. I was in our Bangalore office last week and sat next to a giant gaming machine that's running a 40 billion parameter Llama 2 model on the desk there. And it is capable of a lot of things. It's not going to give you the wizardry that you see from GPT-4, but it solves a lot of problems too.
Well, I think there's an interesting split between the general use of the very general purpose and very, surprisingly useful, but also hyper-specific context, and training an LLM around a very specific context, either because language is hyper-precise, like in a legal or medical realm, or in, gaming or something like that, where you want a narrow way to look at that. So that's one interesting aspect. And the other interesting aspect is, as technologists, we love to peel back abstraction layers and see how things work. And so, that's, you get into LLMs and then start looking at the individual pieces and how they fit together, which is always fascinating.
Yeah, one of the interesting use cases that I've heard about, and we actually have internally a system that will allow you to do this, is you can basically upload a specific document. Maybe it's a manual or a tutorial or something, and then you can use the chat interface to query that document. And so rather than having to page through on the screen, you simply ask, what is the interface for this function, and it will return it to you. And so that, that's one of those very specific contexts where you're using the foundational model as your effectively interface mechanism, but the content itself is very specific to, and this is the document I want you to retrieve from. These are the things I want to know about. And from a knowledge management perspective, that can be incredibly powerful.
One of the things that I found amazing was the explosion of vector databases. that because retrieval augmented generation RAG is probably the most common application that we're building of LLMs, and to be able to do your own embeddings, you need a vector database, and there's a huge list of those. Pinecone's one that we called out, but there are a number of others on there that I think it's great that there's a renaissance in that area.
So for those of us who are not steeped in the AI acronyms, can you describe a little bit what RAG is and retrieval augmented generation, what that means?
I'm not an expert, but we all have to become familiar with these things. So retrieval augmented generation would be where you use some additional information. So whether it's looking something up on the web, but more commonly you have a corpus of documents that you tokenize, create and then embed in your own embedding space. And then when a query is first put into that embedding space, and relevant information, similar information from that embedding space is used to augment the prompt in the LLM response.
So it's a way to refine the results that come out of something to make it more specific and more
specific to your documents and to some specific documents that you might be asking questions about. Yes.
And that's a great example of where, all these tools are available to, for ingestion or, at the beginning of the pipeline or the end of the pipeline. We also talked about a bunch of tools that let you do prompt engineering and save prompts and let you tweak them, et cetera. So, that's the input side, and then you can do things on the output side as well. So there's a rich ecosystem here.
Yeah, that is also partly my hope as well, that we're not going to see that many new LLMs, because in the end, I think the trend, as a regional CTO, I do talk to a lot of the teams that work at Thoughtworks. What we're really seeing is that people are moving away because training an LLM is expensive, and there's still the problem with the LLM making something up, even if the right information is in the training data set. So what we're actually seeing more is that teams are using these foundational models and then have patterns around it, like React or React prompting and others. I'm actually curious to see whether there are any new patterns that I haven't heard so far, because these two other ones were already listed on this radar. So it's going to be interesting to see whether something else was built on top of it. But yeah, my hope really is that we've gotten over the first wave where people were like, oh, LLMs are cool, let me do my own LLM. And then they realize, I need this really expensive professional NVIDIA card. I don't have that. Let's make it run on a gaming graphic card, or let's say make it work on a computer that even doesn't have it. That doesn't have a GPU. And it was just this tinkering. I personally love tinkering, but this is not what the tech radar really is about. So I'm kind of hopeful that we got over that first wave of just trying to replicate, and then, as you said, trying to understand, look under the hood, how did it work? But that curiosity is now filled, and we can now move on to the next step, where we're saying we accept the technology that is there and see what we can build on top of it, what patterns we find, what other technologies we can use, how we can approach this. And that, I think, is what we'll be seeing for, I don't know, my prediction is at least a number of issues of volumes of the technology radar to come.
I do think we tend to take a North American Eurocentric view of these things and forget that not every region has ready availability of ChatGPT or the Anthropic model. So, we have some places are compelled to use a self-hosted model or one that's perhaps less known.
So another theme that is sort of very peripherally related to the AI things that we've been talking about up until now is an age-old topic. And I have to admit that when these blips first came up on our radar, my first reaction was to roll my eyes, because the theme in question is how productive is measuring productivity. In fact, our chief scientist, Martin Fowler, in 2003 wrote a part of his blog wiki, about how futile it is trying to measure developer productivity, because it's this unique combination of creativity and engineering. And there have been all these attempts in the past, but there's this new wave of tools, and I'm usually immediately skeptical. But then as we started digging into them, they actually look more promising, because they're trying to measure actual things that touch on productivity, like, for example, measuring how long a developer can get and stay in a flow state, which is, an actual measure of productivity versus some specious metric like lines of code or something like that. So there's a bit of a resurgence of tools in this area.
There's been a lot of, everywhere I go and when I speak at conferences and things, people ask me about the McKinsey article. So there was a McKinsey article that said, yes, you can measure developer productivity, and that along with the coding assistance, I think, has got people thinking about developer productivity, or we'd prefer to say it's efficiency. It's really difficult to measure, as you said. That was one of the first things I did when I joined Thoughtworks, by the way, was help Martin in trying to analyze our collection of coding samples that we had to see if there was any correlation, between what was in there and the quality and assessing quality. But what we find is that it's really hard to measure. We've tried it over and over again, but what we can do is eliminate waste. Most places that are worried about developer productivity actually have environments that the environments themselves stand as an impediment to developers achieving that state of flow. And so it's much more productive to look at the system in which the developers operate and start eliminating waste piece by piece.
And I would say, from a personal perspective, as I've also worked as a developer in Thoughtworks for a long time, for us, it is okay to be slightly uncomfortable with not knowing the precise, if you could even measure it, the precise gain in productivity. We've had, and I've personally had numerous conversations about the practice of pair programming, which we follow on many of our engagements. And people are then saying, oh, there's two people in front of one keyboard, you must be twice as fast, and so on. And it was always hard. And again, on that level, you couldn't quantify the productivity gains either way. Similar things happened a lot. I mean, for those of you who remember Java 10 years ago, there used to be two major IDEs, Eclipse and IntelliJ. IntelliJ, of course, is not free. It's commercial software, and it's well worth it, I would say. But then again, we had those questions. So if IntelliJ costs X amount of dollars, how much more productive are you? How much time are you saving? Show me the return on investment. And I mean, I guess in that case, at least, it was so obvious that even a small productivity gain that you couldn't precisely quantify would easily make up for the cost of an IDE. But so we're reminded of this, and it is that need in some areas of the business to say, I must absolutely quantify everything, even a creative process that software engineering in the end is, in order to think about it in any meaningful way. And that is what we are really struggling with. I mean, for us, it is not, or for me, I should say, it's not a contradiction to say, I can tell you that there are benefits of using an AI-powered coding assistant, but I cannot tell you whether it's a 10% increase or 20% increase in productivity. And it may actually change from one day to another. And it will definitely, as I've written about in a blog post, definitely change depending on programming language and the area you're working in. But again, the question is, how important is it? Would you really make it contingent on knowing precisely what the productivity gain is to actually trust the team of developers to say, we feel we are more productive, we can work better with that tool?
One of the things that I noticed, particularly in the earlier studies on productivity, was they all focused on speed and completion. And Scott said the magic word earlier, which is quality. And only recently have I started to hear people talking about whether or not these AI-assisted tools are in fact generating good code, or are they just generating lots of code? And I do think that this is going to be something that we need to consider over time, particularly when you think about somebody who is an inexperienced programmer and how they might work with an AI as a code assistant. And I have heard of studies which showed that more senior developers did get a productivity increase. Less senior developers, in fact, took a hit, because if there's, for example, a subtle bug a more experienced developer is going to spot it relatively quickly. A less experienced developer is going to have to spend time figuring out, why doesn't this thing do what I want it to do? So I do think, although I know Erik is quite familiar with the problem of how do you actually measure code quality. I believe we have to get this into the conversation around the use of these tools as well.
Yeah, and Rebecca, in that case, it's not only the productivity, it is also because we often hear that these tools are good for teaching a language. And that is really dangerous because a lot of the examples that are then being used is code on the web. That is example code. And one of the classic ones that I've observed multiple times now is, in languages that have exceptions, you do catch an exception. And then normally when you're writing a real piece of software, you know what to do in the case of an exception. But in an example, that's often the case that you're not really talking about. And you just say, catch exception. And the next time you either put a comment, say, should do something, or you say, throw exception. And I've seen multiple times that the coding assistant was then putting these things in. And if it is meant to teach somebody to program, it is actually teaching them quite bad practices in the end.
We have to remember that the length of time that it takes to find or to assess quality has a big impact on how effective and how productive your developers are going to be. Those long feedback cycles is one of the things that we actually can measure and that we know has a direct impact. So we want to provide that quality feedback, but we want to provide it in an immediate way while the developer's working, instead of having to wait for an environment get provisioned and for a QA to run some tests and so on. So that's one of the things that people can do to actually improve the effectiveness of their developers.
But maybe, and Rebecca made an interesting comment when we bumped into each other at our XConf conference. And because she knows that I, 10 years ago or so, spent a lot of time looking at code quality, and she posed a question to me and said, Erik, could you maybe do better code quality metrics with an LLM? And that is something I've begun to talk about. I don't have any good answers, but I just wanted to say, just because the LLMs, when prompted to solve a problem, may produce certain undesirable patterns as a byproduct, we can, and I think there is a path in there. I agree with Rebecca's suspicion, I guess, Rebecca, that you felt that there should be something in there, that we can use them in a way that would allow them to assess then whether a piece of code has certain characteristics that experienced developers would consider desirable. So one thing that is also interesting in that whole debate about productivity is that there is one set of metrics that we've featured on the radar that I think almost everybody at Thoughtworks understands, that they are sensible metrics, which are the 4 key metrics. And oftentimes I've heard people say, why don't you just use the 4 key metrics then, if you believe that they are, and there's the scientific background and everything, if you are convinced that they are sensible and plausible metrics, why don't you use those to measure developer productivity? The problem here is that there's one massive misunderstanding, because the cycle time or lead time as it is used in the 4 key metrics is the time from checking in the code to deploying to production. So the entire phase, the AI coding assistant is used, namely the programming, is not captured by the 4 key metrics, and therefore they are of little help to really quantify the improvements you could get by using such a tool.
That's one of my triggers. I feel like the 4 key metrics have been taken, used way beyond what they were ever intended or what they empirically were shown to predict. It was about business performance and operations. It was never meant to assess team performance. And yet I see team after team automatically measuring their 4 key metrics and holding them up proudly. And that concerns me.
Well, and that's something else that Martin Fowler wrote about on his blog, semantic diffusion, that once a term becomes popular, the meaning starts diffusing because it becomes just we capture metrics and it's these and these are all we need. So it's something we always have to battle to make sure that technical things still have technical meanings. So let's talk about the last one of our themes, which is around remote delivery workarounds and their maturity. So we were all forced to get better at remote work during the pandemic, but then things eased up and now it's much more of a hybrid model. And we try to pay attention to our ecosystem and, what makes it better and worse. And so we're seeing a lot of the remote delivery workarounds mature by way of fixing broken feedback loops that exist live that got broken with remote. And so we're seeing tools and approaches that are helping us build a nice, effective hybrid model.
One of the things, too, I think is quite interesting in this space is how we are reevaluating what it is that makes particular collaboration styles more or less effective for particular types of interactions. When we did the remote radars, for example, overall, I think the blip stuff worked pretty well, where I really felt, actually, given the subject of this podcast, where I really felt that we didn't get the richness of discussion was, in fact, in the themes. When we are face to face with the themes, everybody gets in front of the board and moves stickies around and adds new stickies, and the level of interaction that we have in that is at a different kind of level. And I think more broadly, as we look at the various workshop formats and facilitated exercises, we are starting to get that meta-analysis, if you will, of what style really, really benefits from face-to-face versus other interactions where it may not be as important.
We should point out that we're all doing this from our home offices in opposite corners of the world. But I was amazed when we did get together face to face for the first time after the COVID and we had been doing the radar remotely for some time, how efficient it was and how much more satisfying it was. I felt like we had a better quality product in the end for having been in the same room together.
There was one controversial point, though. I mean, at some point we realized we're getting almost everything. There was a practice of how to develop software with the word remote stuck in front of it as a proposal to include on the radar, like remote event storming, and I can't remember them all, but there were almost everything that you could just got a remote in front of it. And then we thought, what does it really mean? But what is noteworthy, we had not too long a discussion in the Doppler group, if I remember correctly, to put our perspective and direction on it. And the theme as it stands now on the radar is remote delivery workarounds mature. So we still would consider those as workarounds, making an implicit statement that the in-person format is the default format and the other one is merely a workaround. That got, for the listeners who don't know this, when we write the technology radar, it's the people who are in the group who write the entries, but it gets reviewed by anybody within Thoughtworks who wants to. And that actually was one of the points that triggered a robust debate, I would say, in the margins of the Google Doc where we do the review, for people saying, why are you saying it this way? Why aren't you saying we are switching to remote? Or we are the new normal has shifted or something like that. Why are you just too old as a group that you have to hold to what you've done? But it was really, I assure you, it was a discussion that we had. And yet we do feel many of the formats actually do work better in person. And as if it is possible, we would encourage teams to get together for some of those formats because they are more productive. And as Scott was saying, we're recording this podcast, which is relatively easy, from homes on, I think, 3 continents at least. At the same time, we also know, because we have gone back and forth a little bit with it, creating the radar itself, for example, is much, much easier when we all physically in the same room, despite all the technology we have at our hands.
As I said, I was in our Indian offices last week, and where many people are still working remotely, but there were some teams who were deliberately working in a co-located way, the old-fashioned way. And in that room, you could feel there was energy and creativity happening that you just don't get on a distributed team and a remotely distributed team. And people were learning from each other, and they were excited about the things that they were learning and excited about the roles that they were playing on the project in a way that I don't think you can really achieve when people are disparate and sitting in their own homes.
Well, and I think what we've done with our radar is a good call to action to people listening to this, because it's not that you should go the pendulum swing completely to remote or to completely non-remote, because we've kept some of the artifacts that we created during the remote time. So the way we keep track of things, our blips in a spreadsheet now, we do that when we meet in person now instead of the way that we did before. So we're trying to be sort of meta-analytical ourselves about, okay, what is the real effectiveness of this practice, whether it's in person or remote, and let's try to measure, what's effective for us as a group versus trying to make blanket statements about, whether you should do one thing or the other, and look at the trade-offs for each one, case by case.
I think one of the things we found is that simply translating the things we do when we're co-located in person into a remote format is not the way to do it. If you're going to work remotely and distributed, there are certain things, there are ways of working that are different from and that are probably more effective. I think bringing in this asynchronicity, right? Being able to work so that you don't have to be face to face and you have a collaborative space that you work in. I think that's a key aspect of it.
Okay, well, that wraps up our observations for volume 29 of our Technology Radar. This is always a snapshot in time, so there's no telling what volume 30's themes will bring, but I'm sure there'll be some AI-related stuff on it, but who knows? We'll see, and we'll do another podcast highlighting some of the thought process and a little deeper dive into some of our themes. Thanks very much to my co-host Rebecca and our two guests today, Erik and Scott. Thanks for joining me remotely today in all the scattered time zones we're in.
Thank you, Neal.
Thanks, Neal.
Thank you, Moed.
Thanks, and we'll catch you next time on the Thoughtworks Technology Podcast.